class, I wanted to make an example that's similar to your homework, where you're asked to solve a system of equations with three unknowns using Gaussian elimination with matrices, of course, if possible. So to begin, we would say we're going to rewrite our system of equations, of linear equations, as an augmented matrix. So let me go ahead and do that. Carefully noting that if they ask you to just use Gaussian elimination, that really means our goal is REF form, which REF means ones on the diagonal and zeros below. So everything else, whether it's a number up here, a number up here, a number up here, that's not our problem, but our goal is to get ones on the diagonal, zeros below, and whatever numbers we get on the other side of that line will be helpful in finding our solution. So that's the goal when they ask for Gaussian elimination. If they asked you for Gauss-Jordan elimination, then we would also need to have zeros above the diagonal of ones. And I'll do another video with that example in a moment. Okay, so let's begin by rewriting our system of equations as an augmented matrix. So we write it as the first row being 1, 1, negative 1, 10. Again, these are my coefficients of x, y, z, and my constant column. I usually write that line there, indicating the constant column. Second row would be negative 1, negative 3, 5, negative 38. And catch me in case I make an error. That would mess up everything, so watch me carefully. The third row would be negative 5, 3, negative 4, 27. Okay, once you have your system rewritten as an augmented matrix, you want to analyze what are your allowed row operations and what would I like to do first. Again, with the goal being to get a 1 in the first entry of the first row in the first column here, entry 1, 1. Well, since that 1 is already present, I'll just go ahead and make a marker here. That's already done. So the next thing I would like to do is go to the row right below it and turn that negative 1 into a 0. That's correct. Turn it into a 0. So in order to do that, we have 3 row operations that we're allowed to do. We can multiply a row by a number, but remember I can't multiply by 0. That would kill the entire row. In other words, it would delete the entire equation, which is not allowed. So I can multiply a row by a number, but not 0, so that's not going to help us here. I can add rows together, or I can swap rows. So one thing I could do is I could swap rows if that's beneficial to me. For example, if I had a 0 below here in row 3 and column 1, I could swap it with row 2, but that's not what I have here. So instead I'm going to add rows together. That's going to be my game plan whenever I'm trying to get a 0 somewhere, is adding rows together. But remember, I can add multiples of rows together if necessary. So in this first case, it looks like if I just added row 1 and 2 the way they are and put the result in row 2, I would have a 0 where I would like it. So that's what I'm going to recommend as our first row operation here. And I'm going to keep a note of what I'm doing. Row 1 plus row 2, and then I put the arrow, meaning put the result of that operation in row 2. And I usually like to circle it so I know where I'm actually changing something. Now when you write your new augmented matrix at this step, so we're basically rewriting it as another version of the same thing, but that's more helpful to us. When I write this new version, I recommend that you either do your new row first or copy and paste the old entries first. So let's go ahead and copy and paste rows 1 and 3 since those are not changing in the end. 1, 1, negative 1, 10 remains unchanged, and negative 5, 3, negative 4, 27 should remain unchanged. But let's get our new row 2 by adding rows 1 and 2 from the previous step together and putting the result in row 2. 1 plus negative 1 is the 0 we were after, yay. 1 plus negative 3 is negative 2, so not the best news, but not the worst. Negative 1 plus 5 is positive 4. At least these have common multiples, which is helpful. 10 plus negative 38 is negative 28. So this is where I'm at so far. So now again, I notice that I have got my 0 where I wanted it, and my next goal in getting REF is to get the 1 to its right. So I would like to get negative 2 to turn into a positive 1. And again, I can do that by multiplying that row by a number, adding rows together, or swapping rows. So what I choose to do here most likely is to multiply by a number that would turn -2 into a +1. And the trick here is to use the reciprocal of -2, because the reciprocal times itself is 1, isn't it? So let's go ahead and do just that. For this operation, I'm taking the reciprocal of -2, which is -1/2, and multiplying that by row 2, putting that result in row 2. And again, I like to take a second and copy and paste the unchanged rows from the previous step. So row 1 is unchanged. I'll keep that as 1, 1, -1. Oops, sorry about moving the board there. And 10. And row 3 is unchanged in this step. So that's -5, 3, -4, 27. But row 2 is changing. Take -1/2 times row 2. 0 times anything stays 0. But -2 times -1/2 is +1. So make sure you use a -1/2 so that the negatives cancel each other out. 4 times -1/2 is -4/2 or -2. -28 times -1/2 is +28/2 or +14. Okay, so now I notice what I've done so far. I have the 1 where I wanted it in this row in the middle. And now if I look again what my goal is, I don't need to get the 0 here if I'm not doing Jordan elimination. And even if I was, I probably wouldn't go there right away. So instead I go down to this entry here, and I would like to make that -5 turn into a 0. Okay, so in order to do that, again, I can't multiply a row by 0 because that deletes an entire row of an entire equation. Instead, I can add multiples of rows together, and that's what's going to be most helpful to us here. So what would I need to add? Well, you could think of adding row 2 to it, but notice that 0 multiplied by anything is still 0, so that won't change row 3 when you add them together. However, if I multiply row 1 by 5, 5 plus -5 would be 0. So that's what I'm going to do here. So as I go to my next step, my new row operation here will be 5 times row 1 added to row 3, that's correct, putting the result in row 3. So let's do just that here. So only row 3 is changing, but rows 1 and 2 remain the same. So I'm going to do a little copy and pasting. 1, 1, -110 is still row 1 here. Row 2 is still 0, 1, -2, 14. But the new row 3, after this row operation, to get us that 0 here, we take 5 times the old row 1, which is 5, and add it to row 3, putting the result in row 3. 5 times 1 is 5, plus -5 is 0. That's what we wanted. Do it again. 5 times 1 is 5, plus 3 is 8. Good job. 5 times -1 is -5, plus a -4 is a -9. Nice job. 5 times 10 is 50, and 50 plus 27 is 77. Have no fear, I know the numbers are getting bigger. This too shall pass. Okay, so now we have, taking inventory of where we're at, we have our 0 where we wanted it, right here. So the next step in the process is to get a 0 next to it. So we would like to get this 8 to turn into a 0. Again, we cannot multiply a row by 0. We can only add multiples of rows together to get a 0 here. So we can either use row 1 or row 2. What would be most productive for us? Well, you might think row 1, which would be possible. However, notice that that 1 above would affect the 0. So rather, if you're trying to get a 0 in row 3, I highly recommend adding it with a multiple of row 2. So what should I multiply row 2 by? That's right, -8. So let's do that. -8 times row 2 combined by addition with row 3, putting the result in row 3. And let's see what new matrix we generate here. That means the same thing. So I'll copy and paste rows 1 and 2. So 1, 1, -110. Row 2 is 0, 1, -2, 14. Careful with your signs. And now let's see what our new row 3 looks like after performing this row operation with the intention of turning 8 into 0. So -8 times row 2, that's going to stay as 0 plus 0, which is 0. Good, we don't want that to change. You don't want to undo the great job you just did. Negative 8 times 1 is negative 8, plus positive 8. There's the 0 we were after. Great job. Let's get the collateral damage now. Negative 8 times negative 2 is positive 16. Positive 16 plus a negative 9 is what? Positive 7. So watch your signs. Feel free to use a calculator if you think you might make a mistake going too quickly. Negative 8 times 14, and get that number and add that to 77. And what do we get? Negative 8 times 14, add that to 77. Did you get negative 35? Try it yourself, see if that's your arithmetic. Check me out. Okay, at that step, we have found the 0 we were after in this entry, right? So taking inventory of where we're at and where we need to go, we look now at the entry next to it, and we need it to be a 1. So how can we make 7 turn into a 1? What are your options again? Well, yes, I could always multiply it by the reciprocal, 1/7. And in this case, that's pretty nice, since 35 divided by 7 is 5. In this case, negative 35 divided by 7 is negative 5. So that'll be quite easy to do. Otherwise, what you could do is look at one of the rows above it, preferably row 2, and see that if you multiply a row above it by a number and add it to row 3, could you turn this into a 1? It's possible, but keep in mind it might affect the zeros here. So the reciprocal is your best bet. So let's do just that. 1/7. The reciprocal of 7 is 1/7 times row 3, putting that result in row 3. Let's see what new matrix we've created. Okay, so I'm going to copy and paste rows 1 and 2 once more. 1, 1, negative 1, 10 for row 1, 0, 1, negative 2, 14 for row 2, and my new row 3 will be 1/7 times all the entries, so the zeros remain unchanged when you multiply. 1/7 times 7 is 1, which we wanted. Great job. And again, negative 35 over 7 will be negative 5. Okay. At this step, since they simply said use Gaussian elimination, not Gauss-Jordan elimination, we are finished with finding REF. Notice here, we have our 1s on the diagonal, 0s below. So we have what we call row echelon form. They actually get that from a military formation. You can look that up. It's kind of cool, the name. So let's see, once we have it in this form, it allows us to rewrite the system in triangular form. That's really what this does for us. And we can back substitute then to find our solution. So let's see what we have here. We have 1x plus 1y plus, I shouldn't say plus, minus 1z. So minus z equals 10 for our first row. Then we have no x, but we have 1y minus 2 copies of z equals 14. And then we have no x, no y, but we have 1 copy of z equals negative 5. Notice that triangular form from our previous section? That z equals negative 5 is crucial. As soon as you have z equaling a number, you know that you have a consistent system with one independent solution. So to write your solution set, if you will, because this is a consistent independent system now that we have one variable found already, we'd open our braces and we would put up one single order triple where the z variable is now known to be negative 5. Okay, so how do we find the y variable? Well, this is where we back substitute, right? Back substitute, and we will find that y minus 2 copies of z should equal 14. So plug in your z, which is negative 5, and you get y plus, what's your signs, 10 equals 14. In other words, y equals 14 minus 10, so y must be 4. So now we have our y value known to be 4. And then again, we can back substitute one more time to get our x value. So back substituting these guys in for z and in for y would give us x plus my y minus my z equals 10. So what was my y? My y was 4. What was my z? My z was negative 5. So check that out. You get x plus 4 watch your double negative, plus 5 equals 10. In other words, x plus 9 must equal 10. So we now know, hopefully, what x is by subtracting or thinking x must equal 1. So we now have found the one and only ordered triple in three-dimensional space where the three planes, here, here, and here, intersect at that one point in space, 1, 4, -5. Again, you can check yourself by plugging back into the original system of equations and making sure that all three equations are satisfied, or so like 10 equals 10, -38 equals -38, 27 equals 27. I hope this video was helpful. If you have any questions, please don't hesitate to reach out to me. Otherwise, happy practicing, because math's not a spectator sport. I'll see you next time.